Okay, example 2. Notice that we have a square root of 12 here, and we do a lot of radical stuff. Square roots of things. And hopefully you've done enough of these, some numbers start standing out to you. Like, for example, if you see square root of 25, that equals 5, right? Square root of 36, 6. Square root of 81, 9. Square root of 12, square root of 18, square root of 20, those types of things that have perfect square factors happen also. So if you take a look at this specific term here, I mean, as soon as that popped up on the screen, that immediately caught my eye. Hey, that 12 looks like I can fix it a little bit. All right? 12 is 2 times 2 times 3. The pair of 2's gets to come out like so. So 6 times the square root of 3 is equivalent to 3 square root of 12. And 6 square root of 3 is simpler, and we're trying to simplify, so it's worth doing. All right? So if I do that much, 6 times the square root of 3 minus 2 times the square root of 3 on top over 3 square root of 3 minus 2 square root of 2. And I haven't really focused on the bottom issue yet. I'm still dealing with the top. Anything else I can do? Subtract. I can subtract the top stuff because they're both square roots of 3, right? So that gets me to 4 times the square root of 3 over 3 times the square root of 3 minus 2 times the square root of 2. Always look to simplify using any type of simplification technique you've learned while you're doing problems. Just because, I mean, what happens a lot of times with Algebra 2 students is you see a structure, oh, this is what we're doing right now. We got binomial denominators, so let's just fix it the same way every time. Well, sometimes things that happened before in your life, you know, in math, happen in the problems. And if you simplify that first, it makes the rest of the problem easier to deal with. So now instead of having a binomial in the numerator, I simply have a monomial. The conjugate of the denominator at this point, because I can't make any one of the individual terms any simpler at this point, right? So now I go to my multiply by the conjugate. 3 square root of 3 plus 2 times the square root of 2 on bottom. Multiply the top by the exact same thing. So now instead of having to do a FOIL on top, I just have to do a simple distributive property. This times this, this times this. When I do 4 square root of 3 times 3 square root of 3, the 4 and the 3 make 12. And the square root of 3 and the square root of 3 make 3. When I do 4 square root of 3 times 2 square root of 2, the 4 times 2 makes 8. Inside a radical, 3 times 2 is 6. On the bottom, again, I don't have to do FOIL, I just have to do FL, right? So I do first times first. 3 times 3 is 9. Square root of 3 times square root of 3 is 3. When I do last times last, negative times positive makes a negative. 2 times 2 makes 4. Square root of 2 times square root of 2 makes 2. Until you get comfortable enough to see 3 square root of 3 times itself is 27, just mentally, you know, do it in pieces. 3 times 3 is 9, square root of 3 square root of 3 is 3, 9 times 3 is 27. Okay. What's left to do then is to multiply, add, subtract, whatever we can do. So 9 times 3 is 27, 4 times 2 is 8, 12 times 3 is 36, plus 8 times the square root of 6. Cannot do anything to those two. 27 minus 8 is equal to 19. Yeah. 36 plus 8 square root of 6 over 19 is the best answer to that problem.
We did